In this video, I'm going to go over voltage and current division and do a couple examples. So let's start with voltage division. So let's say we have a circuit that looks like this. Okay, so for example, a voltage source connected with resistors in series. Now, voltage division is relevant for this exact scenario because it's relevant for a series connection of resistors. So what it's relevant for is finding the voltage across each resistor. So like V1, V2, V3. So if we wanted to find either of those, we could use voltage division. So the general formula looks like this. Voltage at any resistor N is just equal to the resistor N over the sum of all the resistors. Times the voltage source. So, for example, if we had a circuit like this, and if you wanted to find the voltage at either resistor, you could use voltage division. So you could say V1 equals 3 over 3 plus 6 times 5, which equals 15 over 9, which equals 1.67 volts. Now, if you wanted V2, you could do the same thing. V2 equals 6 over 3 plus 6 times 5 equals 30 over 9, which equals 3.33 volts. So voltage division, useful for series resistors. So now we'll talk about a similar concept, current division. Okay, so let's say we had a similar setup as before. But now, instead of the resistors being in series, they are now in parallel. So now, if we wanted to find the current through any of these resistors, let's say I1, I2, I3, we can use current division. Now, the general formula for current division says the current through any resistor N equals 1 over the resistance at that resistor divided by 1 over the sum of all the resistors that are in parallel times the current. So, for example, if we had the following setup, now if we wanted to find the current through either resistor, we can call that I1 and I2. We can use this formula. And really, most of the time, you're going to be doing this current division with two resistors. So it can be easier to think of the formula as I1 equals R2 over R1 plus R2 times I. Now, this is basically the same formula as the voltage division, except this resistor on top is just the opposite one. So we want the current at 1, so we're going to have the resistor at 2 in the numerator. So here, if we wanted I1, we would say, okay, I1 goes through the 10 ohm resistor. So we're going to use the 15 in the numerator over 10 plus 15 times that current, which is 5/6, and that comes out to be 0.5 amps. Now, if we wanted the current through the other resistor, I2, it's going to be R1 over R1 plus R2 times I, which is just 10 over 10 plus 15 times 5/6. And that is going to come out to be 0.33 amps. Now, the reason the current division formula is like this is because the amount of current is proportional to the resistance. So there's always going to be more current flowing through less resistance. So you can just inspect this circuit and you can just tell, since 10 ohms is less than 15 ohms, I1 has to be greater than I2 because more current's going to want to flow through the resistor of less resistance. And that is why you put the opposite resistor in the numerator. I1 goes with R2 because the other one is going to tell you and dictate how much current is going to flow through that resistor.